Hello everyone. So I am Dr. John AROCKIARAJ, Vice Principal and Head, Department of Mathematics, St.Joseph's College of Arts and Science from Cuddalore, Tamil Nadu, India. I am going to present you a simple topic on the vector space. First, let's see the definition of an inner product space. A vector space over F is said to be an inner product space if there is defined for any two vectors u comma v belongs to v, there is an element u inner product u comma v. Okay, that is a constant which satisfies these three conditions. The first one is inner product u comma v is equal to inner product v comma u, the conjugate of it. Okay, and again inner product u comma e is always greater than or equal to 0, and the inner product 0 implies u itself is 0. And the third property is that the linear combination alpha u plus beta v comma w, the inner product of that can be rewritten as alpha into u comma w plus beta into v comma w for any vectors u v w belongs to v and the scalars alpha comma beta belongs to f. Now we shall see a process called Gram-Schmidt orthogonalization process. What is the advantage of it? Suppose any ordinary vectors are given. This process helps us to change it or to find a new orthogonal or orthonormal set of vectors. See, it's very simple. How this construction is done? Suppose you are given n vectors. You call it as v1, v2, etc. vn. That is the basis for any vector space whose dimension is perfectly n. Now, from these vectors, let us try to find the orthonormal vector. Similarly, that is also going to be n in number. How it is to be done? We know that the basis contains only the linearly independent set of vectors. Now we start like this. We prove we are going to find the orthonormal vectors w1 etc. wn with a condition inner product wi comma wj is equal to 0, and obviously the unit length will be there. All of them will be unit vectors. What is the construction? First you take the first vector v1, construct w1 by means of v1 by norm of v1. So automatically w1 becomes a unit vector. By taking the inner product, we could identify that inner product of w1 comma w1 is 1. Therefore, see, normally if you divide a vector by its norm, it will become unit vector. So now it is very clearly w1 is a unit vector. Now go for the next construction. I want to find out w2. For that, what I am doing? First take v1, from that w1 has come. Now take the next vector v2. Now I am going to have w1 and v2. What is this construction? Consider alpha w1 plus v2. What is this going to happen? Take the inner product alpha w1 plus v2 comma w1. The inner product becomes alpha into w1 comma w1 plus alpha into v2 comma w1. So not simply v2 comma w1. I know w1 comma w1 inner product is equal to 1, and when alpha is equal to minus of v2 comma w1, it will be true. So we start from, look at the fourth line. I am assuming a new value called u2. u2 is assumed to be minus of v2 comma w1 into w1 plus v2. So u2 is constructed out of w1 and v2. Now identify u2 is orthogonal to w1. How? If you take the inner product u2 comma w1, you will see that is equal to 0. Therefore u2 is orthogonal to w1. So take u2, construct w2 as u2 divided by norm of u2. So now identify w2 is a unit vector, and also we find w2 is orthogonal to W1 because U2 is orthogonal to W1. U2 is the combination of W2. So W2 depends on U2. Therefore, W1 and W2 is an orthonormal set. Now, similarly you continue. Now take W1, W2 and V3 and construct U3 like this. Minus of inner product V3 comma W1 into W1 minus inner product V3 comma W2 into W2 plus V3. Now, if you take inner product U3 comma W1, it will be 0. If you take inner product U3 comma W2, it will be 0. So, what is the condition? U3 is orthogonal to W1 and as well as W2. So, we construct W3 by means of U3 divided by norm of U3. Likewise, you proceed this for W1, W2, W3, etc. Wn, like that. How many values you can go with V1, V2, etc. Vn, I can find like this W1, W2, etc. Wn with the property. For example, you take any intermediate element before Un or Vn, you take the I plus 1th element Vi plus 1. From that, you construct a new Ui plus 1. You see this Ui plus 1 is orthogonal to W1, W2, etc. till Wi. So, this construction helps us to find the next W value, namely from Ui plus 1, we could identify that is orthogonal to all the previous vectors. So, construct Wi plus 1 as Ui plus 1 divided by norm of Ui plus 1. Take this regular formula and apply it for from 1 to n, you will get Wi values. So, this is the simple process to find out if you are given any arbitrary vectors, we can find similarly orthonormal vectors out of it. So, the construction of Ui has to be mentioned very clearly and rest of the things are very simple as you see. Now, look at the case. In this way, given R linearly independent elements in V, we can construct any orthonormal set having R elements. In particular, if the dimension of V is n, we can find n orthonormal set of vectors. So, this process helps us to find from any set of vectors orthonormal set of vectors, and this process is called Gram-Schmidt orthogonalization process or orthonormalization process. Thank you for viewing this.